Section 5.5 talks about counting techniques, and we'll focus on one particular counting technique. And this technique is good for counting sequences of selections, very large sequences and large selections that are difficult to count by hand. And the technique that we're going to do is the multiplication rule of counting. And in particular, the rule is in the slides and in the book, the multiplication rule of counting. And the idea is that when you have a sequence of choices or decisions or selections, and you want to find out how many different ways can you make those choices or selections, all you do is to multiply the number of ways you can make each choice. So ultimately, you end up multiplying, and you can count up the number of possible selections. And we'll do two examples. This is an example from the slides. It's number 36 in section 5.5. And they say, suppose that a compact disc player randomly plays 10 songs on a CD. Once a song is played, it's not repeated until all the songs on the CD have been played. In how many different ways can the CD player play those 10 songs? So, one key thing to point out is that the CD player is not going to repeat the songs. So it's going to randomly pick songs. It'll pick one song, and then the next song it picks out, it is going to pick a new one. It's not going to pick a song that it has already done before. So you could think of this as a sequence of decisions made by the CD player. So the CD player has to decide what the first song is going to be, and it has 10 songs to choose from to start with. It plays a song. Then when it moves on to the second song, it only has 9 songs to choose from because it's already played one song and it can't repeat that song. Then it goes on to its third song, and by then there are 8 songs left that it hasn't played yet, so 8 songs to choose from. On the fourth song, there are 7 songs to choose from that haven't been played. On the next one, there are only 6 songs left to choose from, and then 5 songs, and 4, and 3, and 2, and then by the last song, it only has 1 left to choose from because it's already played all of the other songs. So that the total number of different ways the CD player could randomly select those 10 songs would be the number we get when multiplying each of these numbers of decisions. So we'll multiply 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And it will come out to 3,628,800 different ways of playing the 10 songs. just as a side note, this in particular, 10 times 9 times 8 times 7, can be written as 10 exclamation point, which is called 10 factorial. And in general, n factorial means n exclamation point. That would be n times n minus 1 times n minus 2 times dot dot dot. And you keep multiplying until you get to 1. So for example, 5 factorial would be 5 times 4 times 3 times 2 times 1, which is 120. So factorials come up later in the semester, and it's just good to be aware that if you see those symbols, that's all that it means. It means that you multiply that number times every number below it until you get to 1. So here's one more example. So at Chaffey College, student IDs consist of 9 characters. The first 2 characters must be letters. The last 7 characters must be digits, 0 to 9. Repetition of the characters is allowed, so you can repeat the same character over again. How many different student IDs are possible? And I made another table showing the different sequences of choices that you'd have to make. Let's say that you, Chaffey College is going to pick out an ID for you. And so when the college picks out an ID, when they pick out a letter, they have 26 different letters to choose from for that first letter. For the second letter, they have another 26 to choose from because they can repeat the same letter if they want. So when they choose the first digit, there are 10 possible choices. 0 to 9, that's 10 digits. On the second digit, there are also still 10 more choices, 0 to 9. 10 more choices for the third digit, 10 for the fourth, 10 for the fifth, 10 for the sixth, and 10 more choices for the seventh digit. And like the last one, to figure out how many different possible IDs there are, you would multiply the numbers for each of those decisions. So multiply all of those, 26 times 26 times 10 times 10. Or another way of writing that is 26 squared times 10 to the 7th. And so when you multiply that, it comes out to 6,760,000,000 different possible student IDs. So even if every person in the world was a student at Chaffey College, they wouldn't quite run out of, well, I guess they would run out of IDs if they went past 6 billion, but they would be okay up to that point. Alright, the next video is going to be section 6.1.